Hello friends, welcome to our channel Automation Community. In the last video, we have done ladder programming of on-off multiple fans based on temperature. Today we are going to do its HMI designing and its simulation. So first of all, I will open my DOPSoft HMI software from here. Click on new file. For this project, I will use 800 by 480 resolution of HMI. Now here we will give name to our project. Click on next button. Here in for communication, I will select my simulator that I created in my ComGR. Just click finish button. So here you can see this our workspace is open. Now first of all, I want to display 4 data registers that are my set point 1, set point 2, actual value coming from IO module and converted value in degrees Celsius. So for that, I will click on this data display button and select a numeric display from here. So first of all, I will draw a rectangular box like this. Now as I want, the size of all the 4 boxes should remain same. So for that, I will just copy paste it. Because every time when I will draw, it will be not same size. We will write address to each display. So first of all, select this, double click on it, and here we will write its read address. So what it represents, it is representing the set point 1 which is stored in data register 2. Press enter. From here you can select its style, border color, background color. Right now I will just keep it as it is. Similarly, I will give address to my second block. This is set point 2 which is stored at data register D3. So here I will write D for data register and 3 for D3. Press enter and here click OK. Similarly, double click on this and here I will write D0 because this is the actual value coming from IO module. Click OK. And finally here I will write D1 because this is the converted value in Celsius which is stored in D1. So press enter. Friends, if you have any doubt or if you don't understand why I have used particular data register in these boxes, you have to watch our first part of this video. Now I want one on-off button over here. So for that I will click on buttons and here I will select maintain button and draw a box like this. Just double click on it. If you want round button, from here select round. So our button will be in round form. Now we need to write its address. So click on here. Our inputs are connected at X position and in my PLC I have connected at X0 position. So just click enter. Now we want to give picture to this button. So just click on picture. Here I am going to use modern button library. For the off condition I will use red image. Select it and click on OK button. If you cannot see your button over here, go on stretch mode and select stretch all from here. Now button is visible. Similarly, we will give image to our on condition. So in the on condition, again I will use same library. From here I will select this green image and click OK button. Again we cannot see our button, so click on stretch all from here and now button is visible. So we have changed its shape, give address to it and also given picture to both conditions. So just click OK and our button is created. I will scroll from here. Now we want to draw fans and give animation to it. So for animations, we will use picture display option, and from here we will select state graphic, and I will draw a box over here like this. Now what is the state graphic? It is the animation at the same place. What is animated graphic? When you want to move objects from one place to another like this or this, then we will use animated graphic. But as the fan, it rotates at the same position. So for that, we will use state graphic. Now I will double click on this button. So here you can see state counts, and here it is the read address. So first of all, we will write address. As you know, fan 1 is our output Y0. But to create the animation, we can't write Y0 directly over here. For that, from here we will select internal memory. Whenever we want to do some animation, we will use internal memory of HMI. So it is denoted by $sign. Here I will write 1. You can use any internal memory. I will just use internal memory 1 for my fan 1 and click enter. So I have given address to my fan 1. Now I will go to pictures, and from here I will select vector fan library because I want to use fans. There are lot of different kinds of fans over here, but for simplicity I will just use this first image. As you can see, there are 5 images for the same kind of fan. But why? As you can see here, observe this color blade, and in this image it is this position, and in this image this blade is downward position, and similarly you can observe other two pictures. So what is animation? It is nothing but just changing images, and it will create a rotating effect. So as you can see, there are 5 images for one rotation. So close this, come in the main section, and here in the state counts I will increase it to 5. So there will be 5 states for my internal memory 1. Again I will go to pictures, but before that don't forget to change this state to 0. Now I will give image for 0 state. So go to pictures, again I will go to vector fan library, and for 0 state I will select this image. Click OK. Make sure that your fan is completely visible over here. Now we want to give image to our second state. So again go to vector fan library, and for second state I will use this second image. Click OK. For this state we will use third image. So select third image. Again for this state I will use fourth image. The last state we will use last image. So this is the last image. So how it will work? If the value of my internal memory is 0, it will show this image, and if the value of my internal memory is 1, it will show this image, and if the value of my internal memory is 2, it will show this image. As you can see, the little rotation moment is created over here when I am changing these states. The same thing will occur while doing simulation. The value of internal memory will change, and based on it, this will appear as rotation. So just close over it. This is not enough to create animation of fan 1. we also have to write one programming code in our HMI, that is called macro. So for that I will go on screen menu, and from here I will select screen cycle macro. Let us maximize it. First of all, I will click on this macro wizard. So what we want to check whether our output is Y0 is on or off. If Y0 is on, my animation should start. So first of all, click on command button, select comparison, and from if, I will select if on because I want to check whether my bit is on or off. So I will select this. What we want to check? We want to check output Y0. Just click enter and click on update macros. So you can see our code is written over here. So let me just close it. Now it will check if my Y0 is on, then the code written in the if block will operate. So here I will write code for if block. So let me write $1. This is the internal memory 1 equals to internal memory 1 plus 1. So what this code will do, it will continuously add 1 to the value stored in internal memory 1. So by this it will change its states. And now I will just close this loop and click select end if, press enter. So until my Y0 is on, the value of my internal memory will keep increasing by 1. Now what I want, when the value of internal memory reaches to the 5, it should again start from 0 because we have used 5 images in our internal memory and 5 states. So when it reaches to the state 5, it should again start from 0. So here I will write if internal memory 1 equals to 5, press enter. What should happen? The value of my internal memory 1 should become 0. Again close this loop by end if, press enter. So this was all about the programming for animation of fan 1. Similarly, we will copy this code for fan 2 and fan 3. So select it, press Ctrl C, bring your cursor to here, press enter, and now press Ctrl V and again Ctrl V. Here I will select and press enter. Here I will select and press enter. But don't forget to change the respective values. I want to run my fan 2 animation when my Y1 is on. So here I will write Y1. The address of my fan 2 is internal memory 2. So here also I will change it to 2. Here also 2. Here there is also 2. And last here also 2. So now code for fan 2 is completed. Similarly, my fan 3 animation should run when my Y2 is on and the value of fan 3 is stored in internal memory 3. So here I will write 3. Here also 3. Here 3. And last here also 3. So now I have written code for all 3 fans. Click on the close button and click here yes. Update this edited macro contents. Now as you have experienced, creating this block is time taking process. So I will just Ctrl C and Ctrl V it for fan 2 and fan 3. Don't forget to change its address. Here I will use internal memory 2 for fan 2 and here I will use internal memory 3 for fan 3. Now as we are not going to use actual sensor, so we will give analog input from HMI only. So for that I will select analog slider from here, draw a box like this, double click over it. I will change its type to vertical so that its movement in upward and downward direction. Here we have to write its address. As you know, our sensor value is sent to data register D0. So I will write D0 over here and click enter. Here in the minimum and maximum value, we can select here is 8000. As you know, the range of our IO module DVP04PT is minus 2000 to 8000. That is nothing but minus 200 to 800 degrees Celsius. But in the minimum of this analog slider, we can't use negative values. So I have written 0, and in the maximum, we can write 8000 for our PT sensor. So 8000 will be treated as 800 degree Celsius. But in our project, as you can see, our set point 2 is just 40 degree, and our maximum temperature will be around 50 to 60 degree. So what I will write here, I will write 500 over here. So 500 divided by 10, so it represent 50 degrees Celsius, because if I will write 8000 over here, while doing the simulation, when I will change the slider, it will not change properly as per our requirement. So if I reduce this range, we can change the values properly. So right now for our simulation, I will just write 50 over here. So this slider will change from 0 degree to 50 degree, and click OK over here. All the elements are drawn. We just need to give name to each element. For that I will select text box from here and draw text box like this. Double click over it. In the text I will write, this is my set point 1. Select bold and increase its size from here. You can also change its font and color. Right now I am just keeping it as it is. Click OK. Similarly, I will just copy paste and give name to all other equipments. You can adjust this position. Click on center align to make it align in center from here. You can align center or left right from here. Now I will change its text. So double click on it, go to text. This was my set point 2 and click OK. This box represents the actual value coming from IO module. So actual value of sensor. Click OK. If you can't see your text properly over here, just increase the size of box. Now it is visible properly. Here I will select temperature in Celsius. Click OK. Again here I will increase the box size. This is our start stop button. So I will write start stop over here. Click OK. This is our fan 1. Click OK. Double click on it. This is our fan 2. Click OK. Double click over it, and this is our fan 3. Reduce its size, so we can also give name to here. So we can give name to this also. Just copy paste from here. Change its text from here. This is our analog sensor. Press enter. Click OK. So here we have completed our HMI designing. Now it's time to do simulation. So for that I will open my ladder diagram programming and open my COM/GR from here. Select my simulator and press start button. I have already started it, so just close it. And now I will compile this from here. As there are no error or warnings, I will click download button. So this will transfer my program to our simulator. Just close it. Click on online mode. And don't forget to on this bit. Now I will click on run button. Click yes, and as you can see here, my simulator is in run mode. Now again I will open my DOPSoft from here, and I will click on offline simulation from here. As you can see, our HMI screen is loaded over here. Let's just it to here like this. Now as soon as I will press this button, my set point 1 and 2 will be moved to here, and based on my current value of temperature, my fan will be on. Initially, as you can see, our sensor value is 0, so current temperature will be less than set point 1 and our fan 1 will start. So let me just press start button. As you can see, our start button is on. Our set points are moved, set point 1, set point 2, and as the current value of sensor is 0, which is less than set point 1, so it is the first condition, and in the first condition our fan 1 should remain on. Now as I am increasing the value of my sensor, you can see the value coming from sensor or IO module is 44, but in the degree Celsius it is 4 degree. So what we can say that if I divide this value by 10, I get my value in degree Celsius. Similarly, if I increase my value from analog sensor, let us say our normal room temperature is 25 degree, but at that time my IO module will be sending this decimal value to our PLC. So it is still my condition 1. Now as the room temperature will increase and it is greater than 30 degree, you can see based on our second condition, which is current temperature is between set point 1 and set point 2 and our fan 2 is on, it is rotating. Now if the room temperature keeps increasing and it is greater than 40 degree, so this is our third condition, that our current temperature is greater than set point 2, and in this condition our all 3 fans should be on. So these things you can see from this screen. Now as all three fans will operate, it will create cooling effect and our temperature will become down. And as the temperature is reduced, you can see one fan is switched off, and now as per the temperature requirement only two fans are operating. And as the temperature reduces, now only fan 1 will be operating. So in this way, based on the value of current temperature, my fans are becoming on and off automatically. And if I press this button and make the system off, my all fans are stopped. Again, if all three fans are working and I am pressing this stop button, my all fans are stopped. So friends, this was about our project of on-off multiple fans based on our value of temperature. If you liked our content and want to see more content like this, show your interest by liking and subscribing our channel Automation Community and Instrumentation Tools. Thank you for watching guys. Meet you in the next video.